evening. So I have taken one more example. A manufacturer claims that through the use of a fuel additive, the kilometer per liter efficiency of automobile should increase by 2 kilometers per hour. A random sample of 100 automobile was taken to evaluate these results, and the sample mean was found to have an increase of 1.6 kilometers. Remember, it was clearly mentioned that sample mean was found to have an increase of 1.6 kilometers per hour, and the standard deviation was 0.3, and test the hypothesis that the population mean is at least 2 kilometers per hour. So he's asking us to test a hypothesis with how much sample? 100 sample. So with this basic information, with the information given in the question, first of all we can understand this problem is coming under Z test, because the given sample size is bracket lo n is equal to 100. So when the sample is more than to 30, then we say that it's a large sample. So when we have a large sample, then we have to use Z test. Okay, and in Z test we have various models, but he is asking us to test a claim, so this problem is coming under Z test to test a claim. Now let's write the remaining data. So sample size we have already written, and the sample mean x bar is equivalent to, it was clearly mentioned, sample mean as 1.6 kilometers per hour, and the standard deviation sigma was given as 0.3 kilometers per hour, this one. And coming to the population mean, he is asking us to test the population mean is at least 2 kilometers per liter. So population mean generally representing by mu, which is equivalent to 2 kilometers per liter. Okay, so it's coming under testing of hypothesis. So let's start with null hypothesis. So null hypothesis within the brackets H naught, we will take null hypothesis as, here in this example is talking as claim na. So let's take the null hypothesis as the claim is true, So what is the claim here? They're claiming that kilometers per liter efficiency automobile should increase. They're claiming that it will increase efficiency of automobile should increase the 2 kilometers per liter. So there he is asking us to test the hypothesis that the population mean is at least 2 kilometers. At least 2 kilometers means it might be 2 or more than 2. So that means H naught is hyphens 2, mu is greater than or equal to 2. Remember, whatever hypothesis he is asking us to test, that we will assume as H naught. So he is asking us to test the average must be at least 2. So that means population mean mu must be at least 2, means it might be 2 or more than 2. So that's why I have taken mu is greater than or equal to 2. Then alternate hypothesis bracket lo H naught, we will assume as opposite to H naught na. So opposite H naught is mu is greater than or equal to 2. Now for this, the opposite means mu is less than to 2, because in the null hypothesis we have taken mu which is equal to 2 or more. So then obviously H1 will become 2 ki less than avutundi. So that's why our H1 will become mu is less than to 2. So it is we can clearly observe that it's coming under left tail test, because we have less than. Now coming to third step, level of significance. So it was not given in the question. So let's take 5%. Let's take 5%. Now coming to the step 4, test statistic. So this problem is coming under large sample problem, that is Z test. So our test statistic Z will be x bar minus mu divided by sigma by root n. So this is the formula for testing of hypothesis to test a claim. This implies Z is equal to x bar means our sample mean, that is 1.6 minus mu means 2 divided by sigma means standard deviation, that is 0.3 divided by root n means 100. This implies minus 0.4 divided by, and 1.6 minus 2 is minus 0.4, 0.3 divided by root 100 means 10. That implies minus 0.4 divided by 0.03. So 0.3 by 10 will give you 0.03. So this is equivalent to minus 0.4 by 0.4 divided by 0.03 will give us 30 minus 13.33. Okay, so this is about Z. Therefore Z cal is equivalent to minus 13.33. You might have doubt, sir, we have got negative value now, so should we continue with the negative value or can we convert this into positive? Remember, when you have negative for calculated value, once we need to check for alternate hypothesis. In the alternate hypothesis, if you find a two-tailed test, then only we have to take modulus, but other than we have to leave this as it is. So in this example we have left-tailed in second step, so we have to leave this negative as it is. Now we have to go for Z tab. Tab means tabulated value at 5% level of significance for left-tail test. So for Z test, for 5% level of significance, for left-tailed, our table value is minus 1.645. So once we get Z tab value, Z calculated value and Z tab value, we can go for conclusion. So in the conclusion, we have to check, we have to compare our calculated value with the tab value. If you observe both are negative, therefore Z cal is obviously less than to Z tab because they are in negative. So minus 13.33 is less than to minus 1.645. Got it? So ours is, our value is less than to table value na, so H naught, maybe H naught is true. So H naught is true and it may be accepted. It may be accepted. Hence now we H naught is accepted na? So let's see what we have written in the H naught. H naught is nothing but mu is greater than or equal to 2, and this means the population mean is at least 2 kilometers per liter is true. Hence the population mean is at least 2 kilometers per liter is true. So that's it. So this is about Z test for testing the claim.